The Earth's oceans cradle an incredible 350 quintillion gallons of water, an unfathomable expanse beyond the human imagination. When we dip a bucket into the deep blue, its surface may yield only water, but that mere reflection belies the vibrant ecosystems that thrive beneath. It's a whispered secret of the boundless cosmos. Our explorations, though a fragment in the universal tapestry, have gifted us glimpses of promising exoplanets, planets that might cradle life as we know it. Today, our voyage leads us to the enigma of the Kepler worlds, where imagination dances across the contours of utterly alien landscapes, inviting us to ponder the potential for life beyond Earth. Join us today on an amazing journey as the Kepler telescope has found a planet that is said to be better than our beautiful Earth. The Earth's oceans are home to an incomprehensible quantity of water that underscores the sheer magnitude of our planet's aquatic expanse. When a bucket is cast into the boundless sea, even if its contents reveal only water, it is a stark reminder that beneath the surface lies a thriving ecosystem hidden from our view. Such a simple act encapsulates the profound wonders contained within the expansive cosmic realm of the oceans, a realm whose exploration and comprehension represent but a minuscule fragment of the universe's grand tapestry. And yet, in the grand scheme of cosmic exploration, our endeavors have unveiled a multitude of potentially habitable exoplanets, offering tantalizing glimpses into the realm of alien worlds. In this journey of discovery, we turn our gaze toward the enigmatic Kepler worlds, contemplating the prospect of life on these utterly alien planets. In the quest to locate planets with the potential to sustain life, scientists search for twin Earths, planets that closely resemble our own home. A twin Earth is characterized by its size, which is akin to Earth's dimensions, thus increasing the likelihood of a rocky surface. Moreover, the planet must orbit a star similar in size and radiation output to our Sun, and maintain an optimal distance within the habitable zone, often referred to as the Goldilocks zone. Within this zone, conditions are conducive to the existence of liquid water, a fundamental prerequisite for life as we understand it. Among the most promising candidates for habitable worlds, Kepler 452b holds a special place. It was the first Earth-like exoplanet discovered in orbit around a star comparable to the Sun. This discovery, made in 2015, marked a significant milestone, as scientists deemed Kepler 452b to be the most Earth-like planet known at that time. The rationale behind this assessment is rooted in its star, Kepler 452, a G-type star, similar in temperature to our Sun, but significantly older by 1.5 billion years. Although Kepler 452 is brighter and slightly larger in diameter than the Sun, the amount of solar energy reaching Kepler 452b is only marginally higher than Earth's. The exoplanet itself, with a size 1.6 times that of Earth, exhibits a greater than 50% probability of being a rocky world. Even the orbits of Kepler 452b and Earth share similarities, with Kepler 452b residing in its star's habitable zone, approximately 5% farther from its star than Earth is from the Sun. This extended time within the habitable zone, an impressive 6 billion years, could have granted Kepler 452b a head start in the development of life, although the presence of suitable conditions remains an essential factor. Recent investigations have indicated that Kepler 452b satisfies some of the conditions necessary for habitability. Research suggests that if the exoplanet's atmospheric CO2 concentrations mirror those observed on Earth, it could indeed be habitable. The question then arises, what might life be like in this alien world? Due to its larger mass, Kepler 452b would likely have a stronger surface gravity, causing inhabitants to experience a sensation of being roughly twice as heavy as on Earth. Over time, adaptation could occur, leading to increased bone density and muscular strength. This transformation could be driven by the natural processes of evolution, equipping future generations with inherently robust physiques. Despite these differences, Kepler 452b's proximity to its star ensures a familiar environment in terms of sunlight and surface temperature, maintaining the reliance on photosynthesis as the primary energy source for potential life forms. Moreover, speculation abounds regarding its atmosphere, water reserves, and even active volcanoes. However, a potential concern lies in the risk of a runaway greenhouse effect similar to that which afflicted Venus, caused by high carbon dioxide concentrations. This phenomenon could transform Kepler 452b into a scorching world within 500 million years, necessitating swift human colonization if it is to become a new homeworld. Kepler 452b is not the sole Kepler world harboring promise. There are numerous exoplanets within this system, each offering intriguing possibilities. The great distances separating us from these worlds pose immense challenges for exploration. Even the fastest spacecraft created by humanity, the Parker Solar Probe, would take an astonishing 2.8 million years to traverse the 1/800 light-years to Kepler 452b. The exoplanet Kepler 186f, located within the constellation Cygnus, is a prime example. This Earth-sized exoplanet orbits a red dwarf star, Kepler 186, residing in the star's habitable zone. Kepler 186f's larger size permits a denser atmosphere compared to Earth, potentially enabling the retention and distribution of heat, thereby contributing to its habitability. The neighboring planets within this system are smaller and have shorter orbital periods, rendering them unsuitable for life as we understand it. Despite the vast distances that separate us from Kepler 186f and similar exoplanets, hypothetical future spacecraft with near light speed capabilities could one day enable human exploration of these worlds. The pursuit of the ideal Goldilocks planet, a planet perfectly situated for life, is ongoing, often revealing promising candidates unexpectedly. Kepler 1649c, discovered in 2020 through a review of past observations, serves as a testament to this. Although its atmospheric composition remains uncertain, Kepler 1649c's distance from its star and its shorter orbital period suggests temperatures similar to those experienced on Earth. As our understanding of habitable exoplanets expands, it becomes evident that numerous worlds share resemblances with Earth in terms of temperature and size. Some, like TRAPPIST-1F, TRAPPIST-1D, Teegarden-C, and TOI 700d, are relatively close to us. Despite their intriguing potential, these exoplanets are currently distant and challenging to reach. However, the ceaseless evolution of technology could one day bridge the gap, allowing us to explore these distant cousins of Earth. In the constellation Lyra, Kepler 442b orbits a K-type star at approximately half the distance between Earth and the Sun. Proximity to its host star raises concerns about the habitability of Kepler 442b, as planets orbiting closely often become tidally locked, presenting extreme conditions on their surface. Fortunately, Kepler 442b lies just beyond the range where the star's gravitational forces could induce tidal locking. K-type stars like Kepler 442 are dimmer than G-type stars like our Sun, yet they offer a balance of properties conducive to habitability. Although Kepler 442b remains challenging to directly image, Its potential habitability is supported by a comparative habitability index of approximately 0.84, indicating a relatively high potential for habitability. In the quest to study distant exoplanets, the challenge of immense distances is palpable. However, recent data from Kepler and the European Space Agency provide hope that potentially habitable rocky worlds could be situated within our cosmic neighborhood. This raises the exciting possibility that we may find a twin Earth within a mere 20 light-years from our solar system, transforming our perspective on extraterrestrial life. As we ponder the future, the dynamic nature of planetary systems offers hope that these distant worlds, like Earth's own history, might undergo transformative changes, evolving into environments that bear resemblances to our planet. As humanity ventures forth in its cosmic explorations, the discovery of habitable exoplanets could mark a watershed moment in human history, opening new horizons and inspiring profound shifts in our understanding of our place in the universe. A captivating prospect arises with the notion of large moons orbiting these exoplanets. Studies hint at the potential presence of a substantial moon around Kepler 62e, which could play a pivotal role in fostering complex life. Moons, through tidal forces, influence a planet's rotation and axial tilt, sculpting its climate and providing a shield against spaceborne threats. Kepler 62f, though potentially cooler due to its greater distance from the star, remains an alluring possibility for life. However, the lack of land and metals on Kepler 62f poses a challenge to envisioning technologically advanced civilizations. Yet the wonders of nature remind us that adaptability and ingenuity can yield unexpected solutions, and life on these exoplanets might unveil forms of intelligence far beyond our current understanding. In the grand cosmic tapestry, the potential habitability of Kepler's worlds awakens our curiosity about life beyond Earth. From Kepler 452b's promises to Kepler 186f's distant allure, these enigmatic exoplanets hold clues to our cosmic neighborhood. The ever-evolving quest for habitable planets drives our exploration, fueled by the promise that one day we might connect with another world.